Greetings, astronomy students and curiosos. I am Michelle Kaul, Mrs. Kaul, and I'm going to give you a little introduction to astronomy and cover some of the fundamentals in astronomy before we really explore some other subjects in astronomy in detail. Today is March 31st, 2020, and we are living through a very interesting time. We're going through a pandemic, the COVID-19 pandemic, which has forced us to communicate with students online, which is good because I've always wanted to do online lectures, and this forces me to get it done. So anyways, I want to cover first some of our goals for this class and wrap our minds around the big science of astronomy. So astronomy is a huge evolving science, and it takes a lot of time, patience, and dedication to keep up with, and understanding that you'll never be able to keep up with all the discoveries in astronomy and know all there is to know about astronomy, because it's this constant database that's growing and you're keeping up with. But we want to get a general framework here and give you a good understanding that you could go explore different topics in astronomy. So some of the highlights of this course that we'll cover is we'll first start out with looking at the solar system and all the inhabitants of the solar system, which are planets, moons, asteroids, comets, meteors, and I think I covered all the Kuiper Belt objects. So there's a lot of different inhabitants in the solar systems, which we'll go over. And we'll look at all the interactions of these bodies in the solar system. Then we'll learn about all the different types of stars, like our own local star, the sun, and which is a main sequence star, and some of the other stars out there like red giants. One of the famous red giant is Betelgeuse, which has been in the news lately. And what we also have are white dwarfs, brown dwarfs, pulsars, and magnetars, one of my favorites. So we'll look at many of the different types of stars and some of the evolution of these stars, how stars are born. There's star-forming regions that are certain nebula where stars are born, and how stars die. We'll also learn how stars are grouped together as galaxies, really important, and learn about all the different types of galaxies out there. And then we'll look at the bigger picture and what the galaxies are doing in cosmology, how they're moving further away from one another. And we'll look at things like the birth of the universe and the fate of the universe. Just little tidbits. Can get pretty overwhelming. And then we'll also look at other planetary systems, which is a really new growing field in astronomy. That's the science of exoplanets and discovering exoplanets, and we're starting to see that there's many planets around many stars, which was unthinkable back in the 90s, early 90s when I was a student. When they discovered the first exoplanet in the mid-90s, the number has just grown. So that's been a really big change in astronomy. And one of the other biggies in this course that we want to go through is learn how to navigate through the night sky, understand how constellations are used, which are groupings of stars that allow us to find other objects, learn about the zodiac, and some of the other features that we want to become familiar with in the night sky. Okay, so those are the main basics. So there's a lot there, enough to keep us busy for a long time. But first off, let's start with just what the term astronomy means and what it encompasses, which I think is an important ground to cover. So the term astronomy comes from its Greek roots, which mean astron plus nomos, star, plus law. And we know it's one of the oldest science out there. We know that people have been studying the stars or observing the stars for a very long time. We have recordings of early star maps and early people recording the phases of the moon, etc. There's a lot of archaeoastronomy out there that's fun to explore. So, law of the stars, well, not quite just the stars, we know encompasses more celestial bodies, but it's just a very old natural science that studies celestial bodies, their interactions, and all the phenomena uh, of these celestial bodies using physics, mathematics, and chemistry to explore it in depth. And we know there's a lot of different terms in the field of astronomy. Astrophysics is another term that is used interchangeably with astronomy. Usually, the field of astrophysics um, tends to lean towards more involved physics exploration in astronomy of celestial bodies. But we also have the field of cosmology, which is looking at the origin of the universe and its fate, something that we'll look at towards the end of the course. Also, we have a lot of subfields like planetary science, radio astronomy, X-ray astronomy. So you could see that there's a lot of derivatives of just the field of astronomy and a lot of terms used for that field. Now, one thing that you always want to do, never to get mixed up. Astronomy is never the same as astrology, so never get that mixed up. That's the number one rule of any good astronomy student. And what's the difference? Well, astronomy is science-based. It's science-based. It's based on data and evidence. And astrology is pseudoscience. So there's no evidence, there's no data to back some of the claims, and typically astrology would be having the belief that somehow the planetary positions that you're born into have some sort of influence on your personality, that planetary positions may have an influence on worldly affairs. So none of that we have evidence for. So what we do want to remember is that they used to be coupled together. Astrology and astronomy were the same field, but those sort of separated probably around the 1600s, maybe late 1500s, when there's a lot of key early astronomers that started using data and evidence to develop the field, like Galileo, Kepler before him, Newton, and many, many others. There's a fascinating history of astronomy that allows you to really understand how it's developed. We've come a long way. So anyways, something to always remember, astrology versus astronomy. Okay, our next step then is to start thinking about all the objects and how we're going to, all the objects above the earth, and how we catalog them, organize them, and try to come up with a way of distinguishing them from each other. So there's a lot of stuff out there. There's a lot of star stuff, right? So when we look up the daytime sky, we see the sun, and we're grateful for the sun because it fuels all the life here on planet Earth. So the sun is the dominant feature, and it blinds out all the other stuff during the day. So we can't see the stars. Don't ever look directly at the sun, too, please. So when you're observing the sun, never do that. In the nighttime sky, what do we see? Well, we see the moon, the Earth's moon, and it's not the only moon out there. Usually we need a telescope to see the other moons, though. We see stars, other stars out there. We see other planets. Earlier this evening, I was looking at the evening star, which is not a star at all. It's actually a planet. It's Venus. I saw a crescent moon and Venus. And there's some planets that we just can't see unless we have a telescope. We have an aided eye. Sometimes you get to see comets. We have a comet that might be visible to the unaided eye coming up soon, Comet Atlas. So keep tuned to the astronomy news out there. Those are fun to see. We have meteors. Meteors are really fun to watch during meteor showers, and we'll get some understanding of where they come from, these falling stars. Well, meteor is not a falling star, they're just rocks, but we'll look into that. Asteroids we really don't see, and hopefully we don't see them, because that means that they're really, really close to us. They're usually really dark in the sky. We typically need some sort of aid to see an asteroid. And we do see satellites out there. So we see a lot of artificial stuff. So we see satellites, and that's becoming more and more of a problem because it's starting to pollute, excuse me, pollute the nighttime sky with a lot of extra light. We call that light pollution. And we know the Starlink satellites are growing in number, and that might be hard to do other viewings out there. But if you ever see an object passing by really quickly in the night sky, that's a satellite. Because other astronomical bodies don't move that fast through the night sky unless it is an asteroid or a meteor coming towards the Earth. But anyways, the other object we see a lot is the International Space Station, ISS. We don't see that every time at every location. You could look up Spot the Station. That will give you viewing times for the International Space Station based on your location, a date and time. That's a fun one to spot. And we do see one galaxy without aid if we're at a dark sky site, and that's one of our neighboring galaxies, the Andromeda Galaxy, which is the furthest thing you could see with the unaided eye. So there's a lot of stuff. So you want to start sorting out all that stuff. You know, take a lot of good looks at the night sky. So this is a good time to do it. And our lab will cover some of these basics on observing and try to distinguish what's what in the nighttime sky. And one thing you want to understand is that we're just a small piece of a larger picture, that there's so much out there. And when you do start observing in the night sky, you realize how vast and large and astronomical the scale is out there. And we will do another lab on astronomical scale because the distances are daunting, you know, as far as like being able to travel to other planets or outside our solar system to another star system. That's a big challenge for us. We don't have that sort of technology yet. Okay, and all the stuff we see comes from you know, the initial birth, the energy of the beginning of the universe. So, you know, once upon a time, about 13.8 billion years ago, everything was a singularity. So think of all space-time, all matter and energy condensed down to a point, and then it just went bang. And everything's been expanding and accelerating since, and everything is around us, which makes up the universe. Now, we don't see the entire universe. We could only see what's called the observable universe. So a real fun thing to do, a task, is to look up universe in Wikipedia and give you a sense of how big it is. And look at observable universe and, you know, just skim through it because it gets pretty heavy duty as far as definitions go. But the observable universe is when we place ourselves in the center, what we're able to see based on the light and the distances. So all of that extends out to 13.8. All that started 13.8 billion years ago. And for comparison, our solar system is only about 4.6 billion years old. So one of the curious things is, how do we get all that information? We'll look and explore those questions a little bit more later. Okay, so let's see. Before we start kind of thinking about our place in the universe too, when you are navigating the night sky and trying to understand and catalog everything, there are a lot of great tools to use that. This is a star wheel, and I like to give my students one of these to use in class and lab. And what it does is allow you to see what to expect in the nighttime sky based on the time, based on your location, and So based on your date, time, and location, you could figure out what's going to be the nighttime sky, and you try to look at the constellations that you have on the star map, and you look up and try to locate those. Now, nowadays we have smartphone apps that do that for us. So one of the ones I like to use is Star Map, and of course that makes it easier. You just point at the night sky and you say, hey, what's that constellation? And it tells you. So there's not as much thought into it, and you don't really understand the cycles of the stars involved, how they rise and set, just like the moon rises and sets, and just like the sun rises and sets. So this gives you a little bit more of a sense of how the stars move around throughout the night. So anyways, we'll look into more of that and how to use one of these, or in our case, we'll have to look at interactive sky charts in our lab. Okay, one of the other tools that's been used for eons is one of these things. Another star map. And this is a huge celestial sphere. And what a celestial sphere is a mapping of all the stars around the Earth. So this is a really old model that I love and I use for a lot of outreach. And in the middle is the Earth, and if we plot all the stars around the Earth and extend the longitude and latitude to right ascension and declination, those are the terms we use for those extended lines, we can make a full map of the stars. And that allows us to try to locate and navigate through the night sky to pinpoint where a planet might be, to pinpoint where a nebula might be, etc. So this is a very large celestial globe. Okay, those are fun. So beyond that, we know a celestial globe doesn't contain all the information. So the next exercise we want to look at is where our place is in the entire universe, as I was giving you a little hint of. So beyond the stars that we see in the night sky, there's many, many other stars out there. So the stars that we see in our night sky are just the stars in our in our galaxy, the Milky Way galaxy. So a beginning exercise I also want students to do is to go ahead and try to sketch where Earth's place is in the entire universe. So I like this book about stars that has a great sort of detailed or illustration on how this works. So we have Earth is inside the solar system, which is inside the Milky Way galaxy, which is inside the local group, which is inside this other supercluster here. So what we're going to do is I'll give you a little sketch that I had. Okay, and you could do this on your own and try to map it out and try to think of the scale that we have. So here we have the universe versus the observable universe. And in our observable universe, we put ourselves in the center here. And this is, mind you, not to scale. I don't have enough space to illustrate this. But here we are. Here's Earth inside the solar system, right here. So the Earth is part of a bigger system as it goes around the sun, and we have other planets here. So we have the Earth and the solar system, which the sun dominates the solar system, the largest object in the solar system, and we're inside this galaxy called the Milky Way galaxy, and we're on one of the outer arms. So we have a grouping of stars here, and inside the Milky Way galaxy, we have about 200 to 300 million stars. So those are the stars we try to plot out in our celestial sphere. Very daunting task, and we have sky surveys out there that are continually cataloging stars, and I'll put some links to that in our course page. Now our our galaxy right here, the Milky Way galaxy, is part of a local group of galaxies. And that group of galaxies is part of another group of galaxies, which used to be known as the Virgo cluster, but now it's called the Laniakea. I probably mispronounced it. Laniakea cluster as of 2014. And then beyond that, we have all these other galaxies that are moving further and further away from each other as the universe expands and accelerates. Okay, and that goes far, far out. So, you have to remember that this is huge. The scale is large, and we will cover those topics. So for now, I think I got most of the fundamentals on beginnings of what we're going to cover in astronomy. And the important thing is to learn all your terms, observe and learn all your terms of what's in the night sky. And then what we're going to do is shift to our local solar system and study that in more depth. What we want to know in the solar system are what are all the different inhabitants, how do we decide, how do we distinguish between like a meteor, an asteroid, a comet, a planet, a dwarf planet, etc. So we want to learn all those terms in our own local solar system first, and then we'll start expanding our terms and our knowledge further out. But try to get a good idea on how to map everything out in your mind and wrap your mind around the scale of it. Learn your terms of our basic night sky, and then from there we'll explore some of the solar system dynamics and look at some more detailed explorations of different planets and how moon phases work and more. So anyways, that's it for today, and I'll talk to you, I'll visit with you again online for our next lecture on the solar system. Thank you, and good evening.